All right, so my attempt here is to explain how the Riemann sum turns into a definite integral. And the bridge between is this thing that's called the limit definition. And what we're trying to prepare for is to be able to go back and forth between this limit definition, which may be on the AP test, with that of what happens with a definite integral. Now, we know how a Riemann sum worked. A Riemann sum, what would we do right here? Well, this looks like we did three rectangles. So we'd start by finding change in x, which was the width of each rectangle. And how would we do that? We would do b minus a and divide it by the three rectangles that we have. And it looks like here I did a right sum because what did I do is I went to the right side of each rectangle and I went up there to distinguish how tall each rectangle was, right? So that's the right sum. And of course, you could do the left sum or midpoint sum or different things. We know that if the more rectangles we put in, the more accurate it becomes. So if n is the number of rectangles that I have, and I put in an infinite number, then I know that this is eventually going to turn into the integral from a to b of f of x dx, right? That's how it works. Okay, so here's what I'm going to try to do. I'm going to try to tie this together a little bit better, and I'm going to try to do it relatively quickly. But what we have here is I have this set up as I'm going to add together a whole bunch of products, and the products between f of my right endpoint. What's the right endpoint? The right endpoint being, as I explained for the Riemann sum up here on the top, and then change in x being the same thing that I found up there. Well, the right endpoint can be represented this way instead, where a is the same thing as the a in the lower bound of a definite integral, and there's our, here's change in x listed twice. So what we're going to do is we're going to be able to turn this thing into something like this integral that I have written in the lower right-hand side. So here's what we're going to do. Okay, so we know that change in x is the same thing as finding b minus a and divided by n, because I don't know how many rectangles I need. I know that this is my lower bound. So now let's see if we can take that and let's see if we can turn this definite integral that's down here on the right, and let's see if we can't do the limit definition for that. So I'm going to skip writing the limit, and I'm going to skip writing the sigma because it takes time. We're going to focus on the f of part, okay? So here, f of x, it looks like, is x squared, right? So what does that mean? That means I'm taking my variable and I'm squaring it. So my f of my a plus I times change in x, a being 1, plus, sorry, not I, we use the letter K as our counter, K, because that's the counter that goes with our sigma that we have there. I'm going to multiply it by change in x. Well, what's change in x here? Well, change in x is going to be 3 minus 1 divided by n, or 2 over n. So if I multiply this by 2 over n, and I multiply by a 2 over n here, what I ultimately have is I have the limit as n approaches infinity of this quantity, sigma, right? Got that k equals 1 to n. Well, what's my f? My f is really, instead of doing f, I'm going to write the function squared, right? Just like I have it right here. Well, what's that function? 1 plus 2 times k divided by n, and multiplied by that another change in x. And this thing right here would be a limit definition. So that's my limit definition that I have there. Okay, let's see if we can go the other way now. Okay, so now I scroll down a little bit more, and now I have a limit definition set up here. And what I'm going to try to do is I'm going to try to go the other direction. I'm going to try to turn it into an integral going from a to b. I just got to sort all that out. Okay, so what do we have? So I need to know first off, what's my function? Because I'm going to do f of x. Well, does it look like there's a function here? Well, I see a quantity being cubed. I see 2 times something that looks like this could be construed as a variable, minus 3. I think my f of x could be 2x minus 3 being cubed. That's what I feel like. I'm going to use x's, and you could use whatever variable you want, but I feel like this is kind of how it's being set up. I also feel like there's a change in x right here, which would be b minus a over n. And so we're saying b minus a is the same thing as 3. So that means a and b are 3 units apart. Okay, that's great. And then if I look at this thing right here, this 1 plus 3k over n, well, if I do a plus k times change in x is 3 over n. We got that. Well, then what's a? It looks like a is 1. And if a is 1 and a and b are 3 units apart, that must mean that my upper bound is 4. And there's my integral.